I welcome you all. This video is about illustrative problem. Guess an integer number in a range. In this, we will ask a computer to generate a random number between the range A and B. Suppose A is starting number and B is ending number. So, we will ask the computer to generate random number between the range A and B. And then we will ask the user to guess a number. Now we will check whether the guessed number given by user matches with the random number generated by the computer. If it matches, then it will say that the given guessed number is correct. Otherwise, we will ask the user to prompt guess another number. This process is repeated until the guessed number is correct. Here, one problem is given. We need to write algorithm and flowchart that generate random number between the range. For this, we have to write algorithm and flowchart. So, first we will see the expected output. In this, suppose a computer has selected a random number 12 from range 1 to 20. So, the range over here is starting number A and ending number B. Computer assign A equal to 1, B equal to 20. Now, the computer asks you to guess a number between 1 and 20. So, you guess a number that is 19. So, now you will check 19 whether it is matching. It is not matches, then the guess number too high. Again, it will ask the user to guess a number. If you enter a number is 10, then it compare with the random number generated by the computer. It is not matched, so the guess number is too high. Again, it will ask the user to guess a number. If you entered number is 10, then it is compared with the random number, it is not matched. So, it will display the message like this. Sorry, guess number is too low. So, again it will ask the user to guess a number. If user gives 14, it will display, sorry, guess number is too high. So, definitely the number is between 10 and 14. Now the user guessed the number is 12. It matches with the number selected by the computer. It exactly matches with the number selected by the computer. So now the computer display the message as yes, your guess number is correct. For this, we have to write the algorithm and flowchart. Coming to the algorithm. The first step of algorithm is start. And the second step is we are going to read the starting and ending number as A and B. And the third step, asking the computer to generate a random number between A and B and store the result in a variable called n. And the fourth step, prompt the user to make the guess and store it in guess number. It is a variable name. Guess number is a variable name. Now, compare the user guess number with the number generated by the computer. If both are same, then go to step 5. In the step 5, we are going to print yes, your guess is right, and we are going to end the process. Suppose if the process is not correct, then we are going to step 4.1. Now the control goes to the step 4.1. It is going to check whether the checked number is greater than n. Then go to step 4.2. Else go to step 4.3. And it is printing, sorry, the guess number is too high. And go to the step 4. It will prompt the user to make the guess Once it will guess the right number, stop the algorithm. Coming to the flowchart. First start by the oval shape symbol. Then read A and B by the parallelogram shape. Then asking the computer to generate the random number and storing it in a variable called n. This can be represented by the symbol rectangle shape. Then we are going to get the input from the user and store it in guessed number. This can also be represented by using the rectangle shape. Then we are going to check whether the guessed number equal to n. If it is yes, means then it will print your guess is right, and then it will stop the process. If it is not right, means it will check that guess number is greater than n. If it is greater than n, it will print your guess is too high. If it is lesser than n, it will print your guess is too low. Then both steps go to step 4 to ask the new number. So it will repeat the process. The process is repeated until it becomes equal to n. Then it comes to print the guessed number is right. Then we will stop the flowchart. Thank you. The next topic is Tower of Hanoi. Tower of Hanoi is a mathematical game or puzzle. It was invented by French mathematician in 1883. It consists of 3 rods and a number of discs of different size which can slide onto any rod. The initial position of Tower of Hanoi puzzle and the final position of Tower of Hanoi puzzle is given here. 3 rods are named as source, destination and auxiliary. The auxiliary rod is used to move the disk from source to destination. Here A represents source rod, B represents destination rod and C represents auxiliary rod. Next, the objective of the puzzle. The objective of the puzzle is to move the entire stack to another rod. The puzzle starts with the disk in a neat stack in ascending order of size on one rod, the smallest on the top, thus making a conical shape. The Tower of Hanoi has some simple rules in order to move the disk from the source to the destination. The first rule: only one disk can be moved at a time. The second rule is each move consists of taking the upper disk from one of the stacks and placing it on the top of another stack. A disk can only be moved if it is the uppermost disk on a stack. The third rule is no larger disk can be placed on the top of a smaller disk. This image shows that the 3 disks on the rod A is moved to the destination rod C with 7 moves. The goal of this Tower of Hanoi is move all disks from the tower 1 to tower 3. Next, algorithm. In the first step, start the program. And in the second step, if the disk is 1, that is the total number of disks to be moved from source to destination is 1, means then move the disk from source to destination in the step 2.1. In the step 3, else if we have more number of disks, if the number of disks is greater than 1, then we have to move n minus 1 disk from source to auxiliary rod. In the step 3.2, we need to move the nth disk from the source to destination. And in the step 3.3, we need to move the n minus 1 from the auxiliary to the destination rod. In the step 4, end the condition. And in the step 5, stop the program. This is the algorithm for moving the disk from the source to the destination using the recursive function. Next, and this is the pseudocode of the Tower of Hanoi program. This is the flowchart of the Tower of Hanoi. It is the diagrammatic representation of movement of disk from the source to the destination. Thank you.